Bin.
I'm Faizan.
And this is the Mechaminds Cautionary Vehicle Project.
For the scope of this video, we're going to discuss the problem overview, what we're trying to achieve with this project. We're going to go over the mechanical design, electrical design. We'll perform a demo of the vehicle, and then my partner Bin will go over the programming. And to end the presentation, we'll discuss the skills that we acquired. So to start things off, we wanted to take on the concept of the future of transportation. And with the way things are headed, transportation, in particular car transport, will be fully electric. We want to feature autonomous driving styles within our vehicle and implement a full safety system using our different electronic components, featuring an RGB color sensor, an ultrasonic sensor, a DC motor with encoder, just to name a few.
So it will perform a few safety requirements for a distracted driver, such as stop if there is an object or a dog or a person crossing the street. The vehicle can stop and react before the driver can, as well as the sensor up here can sense red lights, like traffic lights, so that the vehicle knows when to stop before the driver can stop the whole car. So first, we start off with a 1 to 10 scale RC car, mostly because it has a nice chassis that we can work with and the real estate where we can mount all of our motors and sensors and wiring, as well as our external battery pack. We kept most of the chassis intact, and we took out all of its circuit boards and sensors. We were planning to use the DC motor that came with. However, that DC motor did not have an encoder, so it had to go in the bin. We now have a permanent magnet DC motor mounted into the back of the car. And in front, we have the sensors, all connected to a Raspberry Pico Pi board. This is a sleek body that we've cut and drilled so that once mounted, the car can be flush and there is no sensor sticking out, simulating what a real car would look like with these sensors intact. Now for the electric portion of the project, we have the circuit board up here for you to visualize exactly what's going on here. The ultrasonic sensor is powered by V-Bus, which requires 5 volts. It's the only thing connected to V-Bus. And the color sensor, as well as the H-bridge down here, both use 3V3. So the 3V3 powers this lower rail down here. That's this one in the circuit board. And the H-bridge has its own power bank. It's this guy. This is 6 volts, 4 AA's wired in series that can be easily changed like that. Then that goes to the H-bridge, then that goes to the PMDC motor. The PMDC has an encoder, which is connected to the 3V3 rail, as well as the Pico, as you can see here. The Pico controls the ultrasonic sensor, the color sensor, and the PMDC. It's also connected to the H-bridge. It's good to mention that the color sensor, the SDA and SEL wiring has to go to specific pins on the Raspberry Pi or else it will do not work. In this case, we have it in 4 and 7. And that is the overall circuitry of our project. Okay, this is the program for the color sensor. It refreshes every 5 seconds and warns you if you need to stop, and it will stop. So here I'll play it first. I'll put green on it, which will make it go, and red will make it stop. We can do this all day. Put green on the light. Oops. There you go. And then red. And if I keep red here, it won't go at all. That's exactly right. And then we put green on it. All right. So this is the program that controls the ultrasonic sensor. I set it at 10 centimeters for the danger, and if the ultrasonic sensor senses less than the danger distance, then the motor will turn off. Else the motor will turn on. It will refresh every half second. So here we go. Now the motor is going. And let's say I block it, it will stop. And if I take away the object, yes sir.
So next we want to discuss our program, and in lab there was one lab where we learned how to work with DC motors, and then another lab where we learned how to work with ultrasonic sensors. For the scope of this project, we put 2 and 2 together and tried to get the two to work interchangeably. Our primary code, other than defining constants and importing modules and defining the danger distance, consists of a main while loop. If the ultrasonic sensor senses the danger distance, the motor turns off.
Now we will discuss the color sensor program. Now this color sensor, the TCS 34725, is not largely used, so the programs that are available out there are very specific. Some of them don't work, or some of them warn you that they may not work. So the ultrasonic sensor that Faizan just mentioned, we learned that in the labs, so we were able to implement what we learned in lab into this project. For the color sensor, we had to do a lot of messing around. It has a setup base code that's about 30 lines long, and it calls the different colors tuples, and it's very hard to call tuples as variables, such as the ultrasonic sensor has ranges as its variable. We didn't know what to call red, green, and blue. After lots of fiddling about, we created a while loop just like in the ultrasonic sensor program, and we put the entire setup of the TCS color sensor into the while loop. Now this counts the tuples, the 3 values, and then it counts the largest values as the sensor, as the color that is sensing. And then we use that tuple as a variable by stating it within parentheses and quotations. So if color equals red, the motor will stop, else the motor is uninterrupted. Now we state what the color is right above the if-else statement, but within the while true statement, so that every time it loops after the time sleep, it will read the new color or whatever color that was on top of it. Now we've had a problem with this because it would pick one color and stick with that color for the entire duration until the program is restarted. That was because our while loop only contained the if-else statement and not the color sensor setup. So after putting the entire setup into the while loop and trimming the parts we didn't need, we were able to get it to refresh and read new colors every time sleep.
So to end the video, we want to discuss the skills that we acquired throughout this project. For me personally, one of the first things I learned was how to choose the right motor. Our initial plan for the vehicle was to use the ultrasonic and RGB sensors interchangeably with the motor that was provided with the RC vehicle. But then we realized that we were only able to give that specific motor power, and then I was able to really see what an encoder is for, and I was able to physically identify what we can use an encoder for and how it's necessary in our main program, so that we could give commands to the motor based on code we write for the sensor. And secondly, one of the biggest challenges we had was differentiating a tuple between a variable in Python. As been stated previously, we were trying to call the different colors within our color sensor, red and green for instance, out as variables and have the motor perform an action based off of that. but we weren't able to do that. We had to keep the different colors as tuples and go based off of that. So I learned a lot about Python. I learned a lot about hardware specifications and overall how the electronic components and hardware components come together.
For what I've learned in this project, I've learned a whole lot. I really like working with breadboards. It's very black and white. The circuitry is very straightforward. I think the biggest struggle and learning point was with the program. Just like Faizan have said, we have struggled a lot with the color sensor program. This color sensor did come with a package from Adafruit that gave us a program to use and a library to use from, but that did not work in our scenario. The resources for using this sensor with this Pico is very limited, so we had to write the color sensor program up. Majority of it was from scratch. Playing around with different things, it took a couple of days in the library sitting around to get it to work. It's very, very sensitive to ambient light such as this. It will sense as red. It needs to be in a clear environment to begin with. I think it has something to do with initial settings, but after getting it to work, it was very satisfactory, and I look for that feeling in my work field as well. Thank you so much.
Thank you.
Thank you, everyone.